Welcome back, guys, to our DSA challenge series. In this particular phase of the series, we are looking at the questions which are based on dynamic programming. So let us see our today's question. Our today's question is palindrome partition. What does the question says? The question says we are given a string S. We need to partition S such that every substring of the partition is a palindrome. And we need to return all the possible partitioning of S. So first of all, I know you all must know about palindrome. A palindrome is a string which reads the same from both of the ends. From ends, I mean to say from the leftmost end as well as from the rightmost end. If the string is reading the same, it means it is a palindrome. Otherwise, it is not a palindrome. Substring is a string which is formed from the same string. Suppose this is a string AAB. So there can be many possible substrings like A is individually is a substring, AA is a substring, AAB is the substring. It means it should be contiguous indexing of the string. Then it is referred to as a substring. So we need to partition our string S into substrings such that every substring of the partition reads the same. And we need to return all the possible palindrome partition. So I hope the question is clear to you all. Now let us understand this particular question with the help of an example. In example number 1, we are given a string as AAB. So what can be the possible partitioning? For every string, if I partition it individually, means A is a separate alphabet, then next A is another separate alphabet, then next A is another separate alphabet. So every individual alphabet, every individual letter is a palindrome, right? So the one possible case can be separate them individually. It means apply the 4 cuts. First cut, second cut, third cut, fourth cut. Then the substrings will become, one substring will be A, second substring will be another A, and third substring will be B. These all are palindromes. So one possible partition can be this one. Second partition can be A. A is a palindrome, right? It reads the same from the left. If I read it from the left, it is A, and from the right, it's all again A. So it's a palindrome. And the next is B. B itself is a palindrome. So one possible partition is this. In this also, we are getting all the palindromic substrings. So we will return this as our answer. There are 2 possible palindrome partitioning of the string AAB. So we will return it. We need to return all the possible palindrome partitioning. In the similar way, example number 2, only one partitioning is possible, then we will return a single A. So I hope the question is clear to you all. Now, how we are going to approach it? We are going to make separate functions. Let me explain you with the help of the code. This was given to us. We need to return a 2D vector in which there are all the possible partitions. So we will make a 2D vector ANS, that is answer. We will make one temporary vector to store one combination of our substrings. We will make one helper function. Helper function is the main function in which we are going to store our answer variable. And initially, and when the helper function gets over, we are going to return this answer variable. So now let us look at the helper function. You can clearly see we are passing the answer vector as well as the temp vector by reference, so that any changes made in the answer vector gets also reflected in the main function, that is in this particular function. And once the helper function gets over, we are going to return answer. So now look at the helper function. We are going to check. Start is the index. String S is the string which is provided to us. We have made one temporary vector and answer vector, which we have passed by reference. If start is greater than equal to s dot length, it means there can be no further substrings formed. Suppose if a string is of length 4, we can only go till 0, 1, 2, 3 indexing, right? So if start is greater than or equal to s dot length, then what we are going to do, we are going to push a temporary vector to our answer vector, and we are going to return. Otherwise, we are going to iterate through the entire substring starting from start, and we are going to check if for end equals to star, end is less than s dot length, end plus plus. We are going to store the current string, that is substring, starting from start and end minus start plus 1. If valid is current str, we have made one valid function. This valid function will tell us whether the substring stored in current str is a palindrome or not. See, valid is, we have made one function valid, which is going to return a boolean. If it will return true if it is a palindromic substring, otherwise it is going to return false. I hope you all know how to write a palindromic function. We will iterate till n by 2. If s at the index of I is not equal to s at the index of n minus I minus 1, we are going to directly return false. It means it is not a palindromic substring. If the entire loop gets completed and nothing is returned, then we are going to return true. It means it is a palindromic substring. So I hope valid function is also clear to you. If the current string is a valid, if it is a palindromic substring, then valid current str will return true, and this condition will become true. Then we are going to push temp dot pushback current str because it is a valid substring, and we are going to call the helper function from end plus 1. Once this helper function gets over, in our answer vector, all the possible combinations of the palindromic partitioning will get stored. And at the end, we are going to return the answer. So I hope you all would have understood this question. It was simply based on backtracking. So if the question is clear to you all, don't forget to subscribe to our channel and share it with your friends. Thank you.